Okay, so we're going to look at a binomial problem today, a binomial example using the graphing calculator. Okay, so it says the proportion of households in the United States that own a cat is approximately 0.34. Suppose you pick 4 households at random and count the number of households that own a cat. Okay, letter A says verify you can treat your random sample as a binomial situation. So in order to treat something as a binomial situation, you basically have to have a success and a failure. So do you have a success? Yes, your success is owning a cat. Your failure is not owning a cat. Okay? Each trial is independent of the others. That is, the probability of a success doesn't change depending on what happened before. One household doesn't affect another household, so that is true. They are independent. There is a fixed number of trials. Yes, our fixed number is 4. And the probability of a success is within 0 to 1, which is true. Our probability of a success is 0.34. Okay? So then we're going to look at what is the probability that none of the households in your sample own a cat. So now we're going to be in distribution. So second vars is your distributions. And we're looking at 0 cats. So we are doing a binomial distribution. And we're looking at exactly 0 cats, so we want a PDF. A PDF is exactly 0. We have 4 trials. Our probability of a success, P, is 0.34. And our X value that we're looking for is 0. So if you have a calculator that's not a plus silver, it doesn't have those fill-in spots for you, what you're going to enter is your total trials, 4, comma, the probability of a success, 0.34, comma, the answer you're looking for, the number of successes you're looking for. You'll just hit enter, and our probability that none of the households in your sample own a cat is 0.1897, or 0.19. Okay? All right, now C says, what is the probability that at least one of the households owns a cat? So now we're going to go to distribution. And now when we're looking at least one, so we're looking at a range, we're going to want a CDF. And we're again going to binomial, but we want CDF this time. Our trials again are 4. Our p-value is 0.34, and now it's looking for the x value, and CDF calculates the probability of that value and everything less. So if we're actually looking at least 1, we're looking at less than 1, so we're looking at 0, which gives us the same thing because there's nothing less than 0 households. So at least 1 household would be 1 minus our answer there that we just got, because that's everything else. So at least 1 would be 1 and above. What you calculate with a CDF is 0 and below, so 1 and above would be 1 minus the answer. So 81% probability that at least 1 household owns a cat out of 4. Okay, make a probability distribution for the table for the number of households that own a cat. So now I'm going to switch away from the calculator here. And we want a probability distribution table. Okay, so out of 4, we could have 0 households, we could have 1, we could have 2, we could have 3, or we could have all 4. So 0, we knew, we calculated here, and I'll pull my calculator over here. The chance of 0 households is 0.19. So now I'm going to go in and find the chance of 2 households. So again, our trials are 4. Our probability is 0.34. And we're looking at 1 household now. and that's 0.39. And what I'm going to do now is, I think what I can do is I do second entry. So what I just did is I just copied, because I did second enter is this entry. I just copied this, and now I'm going to put in a 2 instead of a 1. So it's just a quick way to do this again. So now I'm going to do second entry again. So it just pulled up when I put 2. I'm going to change that to a 3 and hit enter. And that's 0.10. And I'm going to do it one more time so that I can pull it up for 4. This is just a quick way to do it instead of actually going all the way back into the distribution menu. And I get 0.01. So here's your probability distribution table for the number of households that own a cat. So you have a 19% chance that 0 do, a 39% chance that 1 household, a 30% chance of 2 households, a 10% chance of 3 households, and a 1% chance of 4 households.